Calculus Math 11.
Dots. 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 Today, Chapter 4.3, Solving by Completing the Square. Completing the square is a technique that can be used for different outcomes. In Chapter 3, we used it in order to convert equations from standard form into vertex form, and in this chapter we're going to be using it for solving equations. The two things are very similar, but they give you different pieces of information, so you just need to be careful not to confuse one with the other. Completing the square is a technique that can be used for two different outcomes. So first of all, we've got this question: solve 3x squared minus 9x minus 120 equals 0. Here's how I like to do it. The first thing I like to do is divide everything by 3, which gives me x squared minus 3x minus 40 equals 0. The next thing I like to do is get that minus 40 and bring it across to the other side. Sometimes I do it all in one step so that what you'll actually see in my working is this. Now the next step is completing the square, just like we did in Chapter 3. We take half of the middle coefficient, half of the b value, and square it, adding that now to both sides in order to keep the equation balanced. So that will be plus 3 over 2 squared plus 3 over 2 squared. This, of course, on the left-hand side gives me a perfect square, which can be factored as x minus 3 over 2 all squared. And on the right-hand side, this is 40 plus 9 over 4, which I can put together all as one fraction by giving this a common denominator. 40 over 1, multiply the top and the bottom by 4, giving me 160 over 4, which I add with 9 over 4 to get 169 all over 4. So this is what x minus 3 over 2 squared is equal to. Well, I want to isolate for the x. Right now it's in a term that's being squared. I want to undo the squaring, so I square root both the left and the right hand side. Square rooting the left gives me x minus 3 over 2. Square rooting the right gives me 13 over 2. But remember, the square root of something could be plus or minus. I don't know if this square root is plus 13 over 2 or minus 13 over 2, so I have to allow for both possibilities. Solving for x now, add 3 over 2 to both sides, and this gives me x is equal to 3 over 2 plus or minus 13 over 2. I can take these two possibilities and simplify this out, getting x is equal to 3 plus 13 over 2, or it's equal to 3 minus 13 over 2. This would give me 16 over 2, which is 8, or it will give me negative 10 over 2, which is negative 5. And so I get two solutions for this quadratic equation by completing the square. Could I have factored this? Absolutely. Could I have graphed it? Yes. Sometimes you can't factor them, and that's where this technique works nicely. So what's the process here for completing the square? The first two things that I did were to, one, move the constant term to one side of the equation, and the second thing that I did was to divide everything by a, or the coefficient of x squared. I actually did both of those steps at the same time. You can actually do them in either order. Third step here, complete the square by adding b over 2 squared to both sides of the equation. In other words, take half of the coefficient of x, square it, and add that to both the left and the right. The fourth step, factor the quadratic. Fifth, square root both sides, and remember that the square root can be plus or minus. 6, isolate x and simplify if possible. Here's another example. 4x squared minus 44x minus 101 equals 0. I'm going to move the 101 to the right and divide everything by 4 all at the same time. This gives me x squared minus 11x equals 101 over 4. I don't really want to go to the decimal number here because I don't have a calculator handy, and the decimals kind of make it nasty anyways. Now, taking half of negative 11 gives me negative 11 over 2, which I'm going to square and add to both sides. Probably notice that I didn't include the negative in there, and that's simply because when I square a negative, it comes out positive anyways. It's a little bit of laziness on my part. Technically, it should be in there in both cases. Factoring the left gives me x minus 11 over 2 squared. On the right-hand side, this is 101 over 4 plus 121 over 4. And those will add together, of course, to give me 222 over 4. Now square rooting both sides, this gives me x minus 11 over 2 is equal to plus or minus, I don't know the square root of 222. I'm just going to leave that as square root of 222 all over. I do know the square root of 4 is 2, so that works nicely. And then I can isolate the x by adding 11 over 2 to both sides. Hey, both these fractions are over 2. I can combine this all into one big fraction over 2, saying x plus or minus the square root of 222 all over 2. If I can reduce the square root of 222, I want to, but remember from Math 10, we reduce radicals by looking for perfect squares that are trapped inside. But 222 comes from 2 times 3 times 37, and none of those are perfect squares, so I can't reduce this at all. I just get x is equal to 11 plus or minus the square root of 222 over 2. If I need to turn this into a decimal number, I can do that by getting 11 plus root 222 and dividing that answer by 2, and then by doing 11 minus root 222 and then dividing that by 2. But where do you round off? How many decimal places? Just pay attention to whatever the question asks you for. So that's solving by completing the square. Follow the steps above, do some practice on these. It's kind of tedious, but it'll work every time, at least if there are solutions. Here's a couple for you to try. So until next time, keep your pencils sharp, and I'll see you in class.